Okay, lesson P.3. Definitely review. It's solving linear equations and inequalities. So we're going to go through with a review. I'll point out some details, and then that's going to be your homework. Figuring, going back and reviewing. How do we solve various things? So example 1. Prove that x equals -2 is a solution of the given equation x cubed minus x equals 0. How do I show something is a solution? What makes it a solution? Okay, if you plug it in, it works. Exactly what I need to hear. Go back to that, I don't know, was that elementary, middle school? Plug it in. Does it work? So if I plug in -2, it's -2 to the third minus -2 plus 6. And the question is, does it equal 0? -2 to the third is -8 minus -2 is going to become +2 and +6. And again, the question is, does it equal 0? Well, yeah. My brain says the positive 2 plus 6 is 8. And then -8 plus 8 is 0. So 0 equals 0. So we proved that -2 is a solution. In other words, it's just like checking it. Okay, does it work? Okay, example 2. Solve. You have an equation there. It says solve. I don't need to read it. Okay, what's step 1? Distribute. Hopefully if you've made it to pre-cal, you know the basics here. So when I distribute it, this line reads (4x minus 6 plus 3x plus 3 equals 5x plus 2. Okay, so we know to distribute. What's the next good step? Okay, yeah, I would clean up that left side before I try and move too much around. Too many extra terms floating around there. So like terms, 4x plus 3x is 7x. What about those constants? Well, no, I would just think we're putting -6 and 3 together. They're already on the same side, so put them together as is. Yeah, -3 or -3. So -6 plus 3 is -3. So now I have the equation 7x minus 3 equals 5x plus 2. Now what? Add 3 to both sides and subtract 5x from both sides. It's pre-cal. I am all about doing those at the same time, folks. Algebra 2, I probably killed you guys and wrote them out separately. I'm going to say we're getting our variables to the left. So it's a positive 5x. So I'm going to subtract 5x from both sides. I want my constants, my plain numbers to the right. So it's a -3. So I'm going to add 3 to both sides. Please, by all means, feel free to do those at the same time. So now I have the equation 2x equals 5. And if you feel that you would be better off doing those as 2 separate steps, then by all means, do that as well. Final step, divide by 2. And when we divide by 2, what do we get? I'm going to say 5/2. Did you start to say 2.5, 2.5? Equivalent, right? Improper is just an easier way to leave it. If you wanted to or needed to, you could check this and make sure it works, yes? You could plug it back in. I'm not taking that time. Okay, example 3. Another equation to solve. 5y minus 2 over 8 equals 2 plus y over 4. There's fractions, yes? There's several different things you can do here, but here's my thought. Can we get rid of these fractions? I mean, the fractions aren't very friendly to work with, right? The way, when we have 5y minus 2, we need to either split them up or get rid of the fractions. Do you remember how to get rid of fractions? In other words, how do I get rid of these denominators? What you said, multiply? By what? Okay, yeah. We're looking for, as you look at your denominators, I always think of it as, what would be my least common denominator? If I was getting a common denominator between 8 and 4, what would be my common denominator? We'd have to go with the biggest one, which would be 8. So my recommendation is that we multiply everything by 8. By multiplying by that 8, it's the smallest number that they both go into, we'll end up clearing some extra stuff out. Now, when I say multiply by 8, that means we're multiplying both sides of the equation by 8, right? If you want, what is 8 as a fraction? 8 over 1. Okay. So on the left, what happens when I multiply 8 over 1 times this fraction? 8 on top and 8 on bottom will cancel. And so in this particular problem, what remains? Yeah, 5y minus 2. It was just one fraction, so it made it really easy. Now, on the right side, there's not one term, there are two terms. So first of all, realize that 8 basically has to distribute, yes? So we distribute the 8 times the whole number of 2 is going to be 16, plus, and then we're doing 8 times y over 4. Well, the 4 on bottom and the 8 on top, my brain cancels those. I don't know what your brain does, but my brain cancels those. 4 divided by 4 is 1. 8 divided by 4 is going to make this 2y. Okay. And so 4 cancels, 8 divided by 4 is 2. Once you get those fractions gone, is this a doable problem? Looks much nicer, doesn't it? Okay, so this is where I would say variables to one side, constants to the other side. In this case, I'm going to say what? Subtract 2y to both sides and add 2 to both sides. 5y minus 2y is 3y. If we add the 2 across, 16 plus 2 is 18. If 3y equals 18, then what do we know? Divide by 3, and y is 6. Okay. These things are coming back to you, right? I mean, you guys have been doing that stuff we just did. You guys have been doing that since pre-algebra, easily. So, 7th, 8th grade, you guys have been doing this since. Okay, example 4. Difference about example 4 is instead of an equation, it is an inequality. Besides that fact, we pretty much work the problem the same, don't we? So, we're going to start off by what? Distributing. So when I write out that first line, 3x minus 3 plus 2 less than or equal to 5x plus 6. Next. Yeah. Negative 3 plus 2, they're already on the same side. Clean them up. Negative 3 plus 2 is going to be minus 1. So 3x minus 1 less than or equal to 5x plus 6. Curious, what are you guys going to tell me to do here? Because there's two different directions I could go, and it all depends on you individually. What do you guys do?
I take 5x over because
okay. So you're going to move the 5x to the left? Okay. So, and there's no right or wrong answer. Well, there are wrong answers, but I mean, there's nothing wrong or right about it. Anyways, I'm making things worse there. Okay. He's choosing to go with traditional variables on the left, and that's fine. So if we do that, and actually it gives me an opportunity to show something, we're going to subtract 5x, subtract 5x. If I'm moving variables to the left, then that means I'm going to move constants or numbers to the right. So then the minus 1, we're going to add 1. 3x minus 5x is negative 2x. Less than or equal to 6 plus 1 is 7. Now, some of you moved your x's to the right, didn't you? And if you did that, you have a negative 7 over here, less than or equal to 2x, correct? That's fine. Meet me in the end. What's our last step here? It's negative 2 times x. We have to divide by negative 2. What's the catch you have to remember here? When you multiply or divide both sides of an inequality by a negative, the inequality sign reverses. So this actually becomes x greater than or equal to negative 7 halves. Yes? Now, the rest of you, if you have your x on the right, you have negative 7 halves less than or equal to x, don't you? It's equivalent. I always encourage you to put that x on the right. Now, okay, everyone listening? I'm going to have to figure out a way to make sure my quarantinees know, but, okay. Down at the bottom, it says, write all inequality answers in interval notation. This is correct, but this is an inequality. Do you remember me teaching interval notation a couple days ago? We're going to do interval notation. Now, it doesn't say you have to graph it. I don't remember off the top of my head if you have to graph any in homework. Watch the directions. But regardless of what homework says, I want answers written in interval notation when you get to the end, not inequalities. Now, for the visual of the graph, what does x greater than or equal to negative 7 halves mean? You're going to shade where? To the right of 7 halves. And what goes at 7 halves? A bracket. Because remember, a bracket is equivalent to a filled-in closed circle. I taught this earlier this week. So now, interval notation. Where does this graphing interval begin? The shading begins at negative 7 halves. What goes with negative 7 halves? A bracket. Comma. Where does this shading end? What do we call this? Positive infinity. What do I always use with infinities? Parentheses. Okay, folks. That right there is what I want your answer to look like. Okay. The answer key in the back of the book for odds might have an inequality because some of them, they just want inequalities. I'm asking you to practice interval notation here. Are you hearing me? Understand what I'm saying? So that's why that note at the bottom is at the bottom. Okay, questions otherwise on that one? I mean, it wasn't a difficult problem, really, so. Okay, example 5. We've got 2 more to get through. I can do this. We're good. Solve the inequality and graph its solution. Write in interval notation. So here's the full directions. Not everyone's going to start this way, the same way, but I'm going to ask you, how do I get rid of the fractions? Connor? That's what I would say. Find a common denominator and multiply by it. What do 3, 2, and 4 all go into? What? 12? Yeah. 12 is your least common denominator there. That's the first thing that all 3 of those go into. So that means I am multiplying both sides of this equation by 12. Or excuse me, both sides of this inequality by 12. 12 as a fraction is 12 over 1. Okay, what happens when you multiply 12 over 1 times x over 3? My brain, some of you are saying it's 12x over 3 and you're reducing that, aren't you? I personally cross-cancel. 3 and 12 both divide by 3. So the 3 is gone and 12 divided by 3 leaves me with 4x. 12 times a half. What's half of 12? 6. Still greater than. X over 4 times 12 over 1. 4 cancels, and 12 divided by 4 is 3x. Plus, what's a third of 12? 4. I don't know about you guys, but that's a whole lot prettier. What do I do to finish this up? I'm setting it up so I can move my variables to the left. So to move a positive 3x, I am subtracting 3x. And I'm moving my numbers or constants to the right. So my plus 6, I am subtracting 6. What do we have in that next line then? What'd you guys get? 4x minus 3x is x. 6 minus 6 cancels. Carry down greater than sign. 3x minus 3x cancels. And 4 minus 6 is negative 2. Okay. Am I done? No, that's my inequality answer, folks. Whether the directions say it or not, I want you putting it all in interval notation. So, again, for a visual with the graph. On this, I need a negative 2 on the number. I guess this one technically says graph, doesn't it? Okay. X greater than negative 2. Where do I do? I'm shading what?
Right.
To the right of negative 2. What do I put at negative 2? A parenthesis. It's not equal to, so we're using a parenthesis. Your interval notation looks a lot like that, doesn't it? Okay, interval notation. Ask yourself, where does the interval begin? Where does my interval begin? Negative 2, a parenthesis, comma. Where does my shaded interval end? Arrow represents positive infinity, and infinities always use parentheses. Interval notation, folks. That is what I'm looking for. Whether the book says it or not, whether your odd answer key in the back says or not, that's what I want. Okay. One more. At least I think one more. The back is empty, right? I hope. Otherwise, I'm really in trouble. Solve the inequality, graph its solution, write an interval notation. Okay, guys, the difference is instead of having a left and a right, we have a left or right in the middle. Thoughts?
We're going
Okay, yeah. If we're trying to get x by itself here in the middle, it's 2x plus 5 divided by 3. So how do you undo divide by 3? We're going to multiply by 3. Now, the catch is, if we multiply by 3 in the middle, what else?
It goes on both sides.
Yeah, we're multiplying by 3 everywhere. So 3 times negative 3 is negative 9, less than. In the middle, the whole point is a 3 on top, 3 on bottom cancel. I have 2x plus 5, less than or equal to 15. Now it's instead of getting x by itself on the left, we're getting x by itself in the middle. So if it's 2x plus 5, we're going to subtract 5 on all 3 sides. Negative 14 less than 2x less than or equal to 10. And if it's 2 times x in the middle, we're going to divide everybody by 2. So then I end up with negative 7 less than x less than or equal to, 5. But, not done, right? I want it all in interval notation. Now, this one technically says graph also. If it doesn't say graph and you can just jump to interval notation, great. But otherwise, I'm going to shortcut this one. Let's see, we've got a negative 7, we've got a 0, we've got a 5. I don't normally do that, but I'm just trying to make sure I don't run out of time here. Do you know where the shading's going to be? Yeah, x is in the middle between negative 7 and 5. My shading's in the middle between negative 7 and 5. And always break it down individually if you're not sure. What goes on negative 7? Parenthesis. What goes on 5? A bracket. So there's your graph. And you kind of gotten the hang that the interval notation looks a lot like the graph. Where does my shaded interval begin? Negative 7 with a parenthesis, comma. Where does my shaded interval end? 5 with a bracket. Okay, guys. Interval notation. Make yourself a note. Highlight it. Something. Your homework on page 25. Numbers 12 through 28, 36 to 54, and again, all evens. Okay. Work on that for Monday, please. Monday, my plan will be to do lesson P4, and then I don't know lesson plans done for next week, but my guess is Tuesday we'd start doing just some review over the first half of the chapter. For a quiz, maybe, I don't think I do it as soon as Wednesday, so maybe Thursday. Again,